So welcome everybody to lesson 4. This is building powerful multi-tier, multi-device applications using DataSnap, REST, and JSON. And I'm David I. There's my email address at the bottom. We're going to cover today DataSnap and building mobile clients that can talk to the DataSnap servers. Here's the agenda. We're going to look at some of the technology, and I have an app built that I will zip up for you, and I'll add it to the Code Central zip file that has the slides, and it has a sample Word document that is a draft document tutorial for building DataSnap server and mobile client that is fresh out of our documentation teams, not even online yet, but I'm giving you the PDF version. It's got all the steps you need to use. It's using a different database, not our MastSQL.GDB. It uses the employee.GDB interface file, but the steps that you would use the same. And I followed it myself for using Object Pascal, and everything was fine. It'll be updated, so I'll probably put a few more notes into it and tell you that it's draft 2 or something and include in the zip file. And I'll also include the project that I've built for the mobile client that talks to the MastSQL database that has our customers and orders in it. So multi-tier allows us to scale our applications, put them in high-speed servers, part the business logic, and then connect to them from all sorts of devices: Google Glass, Android smartphone, iPhone, desktop, even a web browser to our DataSnap server. We can monitor what's happening, who's making calls into our database and our DataSnap server. We can use HTTPS protocol. We can encrypt the packets going back and forth between the client and server. All of that is provided for in the DataSnap set of components and infrastructure. There's several ways to build multi-tier. The world has been settling more on REST-style web services versus SOAP, or before that Corba or DCE or remote procedure call systems from before. You'll see Amazon and just about everybody, Google, having REST interfaces, REST-style interfaces for almost everything now. And there, the 4 methods are get, put, post, delete, so it fits nicely into the into a database model, the CRUD model of create, update, delete, and so on. So again, it fits very nicely in database-style operation, but we can also use REST to just make remote procedure calls, pass some parameters, get a result back. SOAP is still there. It's got a lot of different choices for it. Just HTTP seems to be simple, ubiquitous. Open up a port and you're there. DataSnap is a set of components and libraries that we give you so that you can build a DataSnap server that's either a console application, a desktop application. It could be an ISAPI DLL. It could be an Apache module. And that could house your DataSnap server. You could put multiple DataSnap servers on multiple different servers. You can put them on big servers. And in the RAD Studio roadmap, we also mentioned that we're looking at Linux server support. And one of the key reasons for Linux server support to be added in the future is so you can take DataSnap servers that you build, or web servers or SOAP servers, and put them on Linux boxes instead of just on Windows-based systems. FireDAC already has information about how you can do things with FireDAC on multiple platforms as well. And of course, databases, most of the popular SQL databases can run on multiple server-side systems in addition. And the DataSnap components, there's a couple of components in particular that you'll use and want to pay attention to. There's the TDS server component. It manages the DataSnap server operations, the creation and lifetime of the transport, server classes, all of that. You only need one DS server in your server application. The DS server class is the one that has a lot of the logic in it. It's where you define the server-side methods that a remote client is going to work with, is going to call. You can have multiple server classes inside of a single DataSnap server. One of the most important properties in a DS server class is the lifecycle property. Lifecycle property has 3 choices. One is server, and server says that your server itself is going to keep track of all the connections coming into it, all the requests, commands that want to be called. So it's up to you on the server side then to manage the clients and do all the work yourself. The second lifecycle property is session. If you set session lifecycle, then the DS server will create a separate instance of a server class for each active client that's connected. So if a mobile client comes in and you have session on the server class talking to the DataSnap server, it'll create an instance of the server class. If a browser comes in, another instance. A desktop, another instance. 10 mobile, 10 instances. There are also options for setting connection pooling so that as a device disconnects, the connections can stay there, and a next client comes in, you don't have to create a connection, it's already there. The server class, it'll reuse server classes and freshen them. So it's the one that's used by default when you use the wizard. It's the one that's most used. The third lifecycle property is invocation. So for certain operations and certain applications, you might not be involved in a client connected DataSnap where it's calling and doing lots of interactive operations. It's calling methods, sending updates, getting more data, sending updates back, calling remote methods, and then eventually it connects. What invocation does is it'll create an instance when the client connects. And it's used when you have a client that's issuing a command. Like maybe it's just saying, take these updates and update the database. And then it does that command and the connection gets shut down. Maybe you'll have a retail application where you have all these remote retail centers calling into a DataSnap server, or at midnight in a data collection type system, each one of them will call, send some data, and disconnect. They're not involved in a conversation method call. They're just going to call one method and go away. So you could have a server class for that kind that would have invocation as its life cycle. And again, a DataSnap server can have multiple server classes with multiple different life cycles property settings. The DS REST connection is the component you put on the client side, and it provides the client side equivalent to the back end of your DataSnap server to make the connection through the port, the IP address, or host name. It also is used to create the client side method declarations for whatever methods are in the public section of the server class. So the REST connection will generate using the proxy generator that's put inside. It's called, where is it? It's TDS proxy generator is the component. That's inside of your DataSnap server. It reads the server class public methods and will generate the interface units for you to include in your client. And then if you change server methods, add some more methods, change some parameters, change a name, delete a method, all you need to do is right mouse click on the DS REST connection component in your client side, and there's a pop-up, I'll show it to you in a moment, that says generate the class interfaces, and then that's how you update your client side based on the server. You could also write code to do that on the fly if you want to, but normally you would do that at design time. The REST web dispatcher is also there in your DataSnap server. You have the option in a DataSnap server of having a browser sort of test harness interface, or to serve up JavaScript for the method calls, HTML for a user interface if you want to have a browser or browser-based client use of your DataSnap server. You'll see that in a moment in action. It's optional. There's a checkbox in the wizard. The DataSnap REST itself sits on HTTP. So our DataSnap REST component, set of components, also sits on HTTP, but there's also an option in the wizard, or you can do this in your code, to have it use HTTPS. Also on the transports, you can specify filters, and filters are just bytes in, bytes out. So whatever your client is sending to the DataSnap server, whatever your DataSnap server is sending to the client, that can be sent through a set of filters, including a custom filter, where again, you can do whatever it is you want to do to the data, transform it in somehow. We provide two sample filters for encryption, PC1 and RSA. These are not strong encryptions. They're just there as an example. And also a compression filter that uses the zlib library. There's resources in the slides at the end to point to some additional filters that are out there for DataSnap. Daniele Titi from BitTime, our partner in Italy, wrote a blog post and put some additional filters up in a Google Code area, and I have the link to that inside of the resources of the slides. So you can do operations on the filters. You define these filters and the code for the filters on the DataSnap server side. When the client connects, and if there's any filters, the DataSnap server will send the filter information down to the client so that you have the right code that can execute on client and server side. So if you're encrypting and then compressing, or if you're compressing and encrypting, it'll make sure it does the right opposite things on the client side. So you don't have to worry. Just define your filters on the server side. All of that is covered in Pavel Glavatsky did some articles, and those are linked off the resources. He's done videos as well at Code Rage and elsewhere about how to use filters and authentication, authorization, and so on. So here we're just going to cover the base level of building a DataSnap server, building a mobile client that uses it. There's a DataSnap wizard. It's file, other, and then put your language in this case, Object Pascal. Go to the DataSnap server page, and there's a DataSnap REST application wizard. And then through the different pages of the wizard, you can specify ports, protocols, and so on. And then the REST clients use RESTful interfaces using the FireDAC JSON reflection technology that we have, and you'll see that in action. And also there's apply updates. Each of the cached updates in FireDAC can keep track of the deltas or changes you make. And then you call apply updates, you send the deltas from the client to the server. The server will see these as a deltas call. It will formulate the SQL update statements for you. You don't have to deal with that. And it will send the updates back to the backend database. So it's all wrapped up in a set of components and a little bit of code. And then the rest of it is all magic. I've got here some of the sample code. We'll just look at that in action. There's a get departments. This is from this Word document. And then you'll see, for example, we'll set the query false, and then we'll create a JSON dataset object, and we'll use this dataset writer list add method of the dataset writer, passing it whatever the query is that we have. In this case, the example was for department names versus customer names in our master detail. For apply updates, we just create a JSON Delta apply updates interface, and then we get from the department the command to apply updates on the server side, and the same thing for any other updates that we send, for example, any customer and order changes that take place. On the client side, to get the query, we just say we close the FDMEM table. That'll clear out the FDMEM table. And then we'll call the remote method through the client module server client. You'll see this in a minute, call get department names. And then we'll append the data to the FDMEM table for the data in the JSON packets using the JSON dataset reader interface. And then we'll open up the FDMEM table, and we'll see through live bindings the data showing up. And apply updates from the client side is just go through each of the tables and use the JSON deltas writer and write out anything that was changed in this case, employee and department table, or it could be customer and orders table. And that's that. So let's go look at a couple things in the IDE. Also, I want to show you, this is the Word document that uses a different interface database, but the steps are the same if you're using our MastSQL. This one uses the employee database, which is also an interface sample database. And it's, again, step-by-step tutorial for going through the wizard, and it gives you the source code that you'll add and tells you where to put it. So here he's defining on the server side an interface get department names, which is a data set, and then the code here that creates that object and returns it back as the result, right? So it creates it, and then the writer writes it out So step through and take a look at that draft. It's in a PDF form. That's part of the zip file along with the slides. All right. All right, let's go to the ID, and let's start by using the wizard, File, New, Other, Object Pascal, DataSnap Server. So here's the DataSnap REST application. So it's a REST application that uses JSON and so on. We have 4 choices: standalone, standalone console, ISAPI DLL, Apache Dynamic Link Module. Marco Cantu is doing a skill sprint tomorrow on using Apache dynamic modules and how to use that with our products. So you could choose that option and run a DataSnap server on Apache or run an ISAPI. These will be higher performance because the DLLs sit in memory, the module sits in memory, versus starting up an application and then having it sit there running and waiting for operations. But you can do those 4 different architectures. Here you'll specify the HTTP port for your REST DataSnap server. You can make sure that port is open. If you're not sure, click Find Open Port. It'll find an open port in your infrastructure. If you want HTTPS, then check this box, and when you go to the next tab, you'll need to specify a certificate. And Pavel Glavatsky, I have a link for how to create a development certificate with OpenSSL. If you want to put in production, then go to VeriSign or somebody to get a production certificate. All right. And then the next step is if you want any authentication, authorization, username, and password. There's also role-based. Pavel has a whole set of tutorials in his DataSnap Labs for Delphi that takes you through simple DataSnap remote method calls through authentication, authorization, the role-based system using attributes that defines which client applications can connect, which can see which interfaces in your server class. And then this wizard generates a couple sample methods, including if you want to have a browser interface and some JavaScript and HTML that you could build maybe another client. Maybe you've got some PHP thing that needs to talk to DataSnap. Then the sample web files get generated. And then you'll choose either a key component to put your code for the server class, or if you want to have database access components, then you'll choose a data module. Right? And then a place to generate it. So you just generate, and what gets generated is a user interface, because I said I wanted a standard FireMonkey client application for Windows. There's a couple buttons to start the DataSnap server and stop the DataSnap server. Here's the port that we want to use, and here's a button to open the browser interface, which will just use the shell execute to start up whatever your default browser is, and it gives you a nice little sort of test interface of your DataSnap server, and the and to look and see that it's all okay and running. Server methods is the data module where we're going to put database access components. It's also in the implementation section, the public section of your server methods class. 2 sample methods get generated if you have that checkbox in the wizard: echo string that takes a string and returns a string, and the reverse string interface. So here's our 2 remote interfaces in our DataSnap server. And then down in the implementation section, we do the implementation of both those methods. So echo string just returns the value that's sent. Reverse string will reverse using the string utilities, reverse the string and send that back to result. And under the covers, all of that will be passed back and forth using JSON, and that's done by the DataSnap infrastructure. The web module has the DS server. We've set it to auto start because we want to have it when we run the DataSnap be ready for commands. If you only wanted your DataSnap server to run at midnight and for 1 hour, you could put a timer. You could make it a cron job so it would start up and auto start. You could also have a button if somebody's monitoring it and starting and stopping it to set up to turn off auto start and just call start. It's got some events on connect disconnect, so you might use this to log clients, time, and device or whatever else, IP address, as clients connect, and when they disconnect, you can use these for logging and other operations. The server class has that lifecycle property that we talked about. So here's the three choices. Session, the wizard generates by default, where one server class instance will be created for each client that's connected and active. You've got server and invocation there as well. Here's the REST web dispatcher. So when REST calls come, they're whatever the name of your host is or IP address, REST/datasnap/datasnap/. So if you want to change the context, you can put different strings in. Session timeout. There's a few events, authentication. Manager can provide one of those, and so on. And then here's the file dispatcher. We've got our proxy generator. That's the thing that's going to generate the class declaration and the method interfaces for all the methods in a server class. And then a DSS server metadata provider. If you've got any database operations, it knows how to read the metadata and deal with it. And we've got a page producer for our web interface that's going to let us test one of the methods, in this case, the reverse string method. There's also a function invoker if we've got our clients connected in that are calling the methods so that it actually does what it needs to do. So let's go and run this DataSnap server. And we'll say start. We could change the port, but let's start it. And firewall, since I'm using a port and it didn't know about this application before, so we have to say yes. We'll let it do HTTP. We can bring the browser up, and the browser, again, the wizard generated this sample HTML so that we can just call a method in our DataSnap server and test it, and reversing it back and forth. It also has a link for server functions. Here are a bunch of the administration server functions, like list the classes that are around, for example. And we see the classes DSAdmin, DS metadata, and the tserver methods one class. So that's coming back as JSON down here in this little world. So if I can remember what my server method class name is, that's one option. You can also not give this or deploy this interface. For the server methods, we get all of the public methods that are inside of the server class, and it's a nice little test harness. So hello will execute. So now it's a browser client calling into our DataSnap server. Here's the echo string hello world, and we'll execute, and the JSON result is it was sent hello world. The result coming back is I can't say that, Deloro Ole, something like that. All right, so it's just a little test bed for our browser test bed if you want to test the different method interfaces inside of your server class. All right. So the next thing I'm going to do is I'm going to open up an application that I've built, a project group for a DataSnap server that I followed the steps in that Word document draft that you have for, in our case, using the MastSQL database instead of the employee.GDB interface file. And I built a user interface for this database, and I've got a list view here where I'm going to put customers. I've got a list box up here with a list view here with the orders for the specific customer that I select. And I've got a settings tab where I can specify the IP address of my DataSnap server. It might be in Amazon Cloud. It might be running on my Windows Server somewhere. Set the port, and I'm not doing any username password right now, but if I had authentication and a manager in my DataSnap server, I'd want to be able to pop up an input query or put on my settings tab my username and password, for example. When I build my client and you follow the steps, I'll build the user interface of it. If I want to connect to my DataSnap server, I'll go File, Other. And under Pascal projects, you'll notice now there's a DataSnap REST client module that I can choose. And the REST client wizard will provide the easy way to get the client interfaces from a DataSnap server. So over here on my client module, I've got my DataSnap REST connection. So this was generated and added to my project by that wizard. And the REST connection has here the port, 8080. It's got the host name, right now, localhost, fine. Again, the DataSnap path the REST context / REST. So if I change that on the server side, I need to change that over here as well as part of the URL that is happening under the covers. There's an option here under connection for keep alive, and that's set on by default. And what that does is that if that's set, then the client will send these keep alive little bit messages back to the DataSnap server to say, DataSnap server, I'm still here. Maybe I'm doing something, waiting for the user to type in some data or whatever. So I don't want to get disconnected because of no activity. And so you can set the REST connection component to do that automatically under the covers for you. All right. The other option, the other thing the REST connection gives you is you can make sure your DataSnap server is running, and it isn't because I forgot to start it. So let's go back to the DataSnap server and let's run it without debugging. So here's my DataSnap server, and let's start it. Right? Because remember, I had that generated one before, but this is actually my Marine Adventures DataSnap server now, and then the client that processes it. So the DataSnap server in this case has the server methods, and in the server methods, I've got my Fire.connection to interbase. So it's using interbase, and let's bring up the connection editor. It's going out to our MastSQL.GDB file. I've got username and password. I've got a login prompt turn off, and I'll activate it so it'll be active when we run. Let me go back here and stop this again for a moment. Okay, and then I've got three queries. I've got the query for customer names, and the query for customer names just says select Custno and company from the customer table. So we can execute that, and it'll just give me two columns that I can use to put into the user interface of my mobile application so that I can select a customer and then see the orders for that customer. The second query is query customer where the Custno equals some customer number. So when I select a customer in the mobile client customer list view, I'm going to pass back the customer number and then through a DataSnap method. And then it's going to fire the query, and it's going to build a JSON packet of the customer data and metadata coming from that query. And I can test this at design time as well. Just put a value in for the parameter, and that would show me that a customer 1221 will give me the company information for Kauai Dive Shop. And then the third query here in our DataSnap server is select star from orders, where the customer number for the order is equal to some parameter we'll pass. So again, we'll go in here and say, show me all the orders for the Kauai Dive Shop. And so we get all the order data. Again, these are going to be packaged up into JSON and set to my mobile client. And then, a couple of supporting, we talked about these last time, the physical link component and the GUI wait cursor that you might want to display as the command is running. The server unit is that starting interface, and the web module unit, again, is all of those bits. There's a couple in my server methods, which has the database access. I've also declared three public methods besides the two sample ones that get generated. Get customer names, which is just going to return a data set as FD JSON, and that customer names is going to have the Custno and the company string in it. There's another one called get customer names, which also is going to return a data set. That's going to give me so that the second one is customer orders. That's going to give me, if I pass it the customer number, it's going to return data set with the customer information and the orders information for that customer. And then I've got an apply changes for customer orders. That's just a starting point. If I want to change any customer data or change any order data, then I'll pass the delta list as a parameter from my mobile client, and it'll come back in and process those on my back end in my DataSnap server. The implementation of these three methods is down here. Get customer names. I'm going to take the customer names query that's on my DataSnap server and set it false. And then I'm going to create a data set. And then into the data set, I'm going to use the data set writer to run the query and add that to the result, which is the JSON data set. So this TFD JSON data set writer is the call is the JSON interface to call the method that'll take my dataset data, metadata and data, and put it in JSON and send it as the result of this remote procedure call, a function call from my client to my DataSnap server. The get customer orders, I'm going to pass it an ID, which is going to be my customer number string. It's going to return a JSON data set. Here I'm going to set the parameter of my customer to be that customer number. That's for that parameterized query. And I'm going to set that in the params for the customer order query. And then I'm going to create the data set, and I'm going to do two data set writers, one to pass the customer data. So here we've got two strings defined, customer and orders, and that'll be part of the JSON packet so that I can pull apart on the client side the part that goes into the customer and the part that goes to the order. So I can do both queries, slam them together into one JSON result and return it. And that you calls dataset writers twice to append to the result the customer query and the customer orders query result. And then the apply updates code is here at the front that just says we're going to get a delta. We're going to get deltas, and the deltas, I'm going to use that same string. I'm going to find the customer deltas, and I'm just going to use the query and call the command to apply the updates, and it will do it for me. I don't have to do anything else. It's all done by DataSnap. And the same thing for any order changes. I'm going to apply updates for the orders. So this call here, if I get any errors on my apply updates interface, then I'm going to raise an exception or put up a box or something, send an email, whatever it is that something bad has gone on. Database is corrupted, somebody's changed the data from the time it was sent to the client, whatever it might be. All right, so that's the server side code. On the client side, the user interface, I've got a button here, and this button is going to call get customer names, and then I'm going to set this active control. So how do I know what get customer names is? Well, I've got a method called get customer names, which is going to define something which is a data set list. I'm going to close the FDMem table that'll empty the memory table, so that way if I click a button to go get customer data, I'm not just getting the same customer data multiplied multiple times over into my result of my mem table. So I'll close it to clear it out without saving it. Then I'll call the client module one server methods client get customer names. That's the method over here on my server, get customer names, which is going to read the query, write the JSON, and return it as a result back. Client module server methods client get customer names. That's the implementation. And then for the FDMem table, append the data using the JSON dataset reader and get the values back, and then open the FDMem table, and then live bindings will show it at runtime. And then there's also a get customer and orders method in my client unit, and that's just going to call the client module server methods client get customer orders, where we're going to pass it the customer number. So that's the remote call to our DataSnap server. And then I'm going to pull apart based on using these strings that come back. I'm going to get the JSON reader, and I'm going to say get me the list values by name. So anything in the order section here, anything in the customer section of the JSON there, those get put into the FDMem table for customer and orders, and they're activated with appending data, and everything's good. So I've got a couple event handlers. On the customer button, I just call get customers and activate the first tab. And then on the list view for customers, I've got an on change. List view customer change is going to get the detail property of the selected list view item, and I map the customer number to the detail with live bindings. I'm going to pass that customer number to the get customer orders code that I have up above, and it's going to then do the remote method call, right? Get customer names or get customer orders, either one. In this case, customer orders. And then I'm going to activate the customer orders item, tab item. And again, live binding is going to map the data into that view. If I change something, let's go and make sure if I started my server. I still haven't started that server, did I? Did I start it already? Oh yeah, it's running. No, it's not. Okay, let's run the DataSnap server. Start it. Okay, it's running. If I change any of the interfaces on the DataSnap server side, first I can make sure that it's running, test connection successful. If I change any of the interfaces, the parameters, add some new methods on the DataSnap server side, I need to generate those client classes unit again. So I right mouse click, and there's called generate DataSnap client classes as a choice. And that will just update all that generated code for the client classes unit that has all the different underpinnings here with some sample methods and data, and then all the commands that happen under the covers that package up any parameters and send the JSON over to the back end. And so for each of those, reverse string get customer names, there it's packaging up everything. There's the get customer names, get customer and orders method. There's customer and orders. And then it prepares it and sends it off to the DataSnap server. So that's all happening, and that's all that code is generated automatically by querying the DataSnap server methods and their parameters. We generate those so that all I have to do in my client interface is call this method, for example, client module 1, server methods client get customer orders, and pass it a parameter. So it makes my life in programming a lot simpler. So my DataSnap server is running. Let's go to the device, REST client Object Pascal. So first thing I need to do is go to the settings page. And since I'm not running a sort of Windows test version, I need to put the IP address, which is over here. And it's 10.20.5.62 is where my DataSnap server is running. So we'll save that setting. And now go back to the customer. If I click the customer button, it's now made that call over to my DataSnap server. The DataSnap server fired the query, and it's returned back the company and the custo into a list view. So if I select, and there are all the customers that we have. So if I select one of them, then that customer number was passed as a parameter to the get customer and orders over on the DataSnap server. It formulated it all in JSON both directions. It brought it back. We pulled it apart. And now I have a list. I have the company name in a list box at the top. And I have the order date and the order number in the list view down below. And I just haven't finished the part where I want to click on the order and switch to another tab and see the order detail items, make any changes, hit save, and then eventually hook up the apply updates button, right? We can go back to customers and pick another customer, and it'll fire off. Since I close the FDMM table, if I click the customer button, refires the original query and populates the FDMM table. I can select a different one and come back. If I go back to the customer tab, it doesn't have to fire the query because it's still sitting there. But it will fire the query to get their orders because it only brings back the orders for the customer. Select Android, Object Pascal version of the DataSnap client. Let's go to the settings page. So let's cut that, and it's 10.20.5.62. Let's save that. Let's hit customers. There's the customer data, and we can scroll through it. That's the list view. So we'll click customer and then see the orders for that customer. That's in a list view with a list box at the front. And then we can go back and click another customer and so on. The other thing is that you saw in the source code that I closed the FDMM table, which clears out the FDMM table since I haven't saved it. I'll add some code later to the final project so you can save the data that's cached on the mobile client. That way you could disconnect from the DataSnap server, come back in, load the saved data, because the FDMM table can save to XML, JSON, and its own binary format. And then we could just continue editing things and then call apply updates to send all those changes back from the FDMEM tables. So we don't have to worry about hitting customers and it calls append data, because by closing the mem table without saving it and restoring it, it clears out. So there's the same DataSnap REST client, Object Pascal, running on Android, same source code that also runs on iOS. If I go back to my IDE, that code is happening here on my list view. When I go list view customers change, I'll get the selected detail item, and I did live bindings. I set the detail to be the customer no. So the list view of customers, I have the detail item getting the customer number. So when I click on an item in the list view, I'll use the detail to fire the query that then the orders list view gets the FDMEM table that's come from our DataSnap server, and it populated the text and detail, the order number and date, for example. And here's where I take the FDMEM table customer that we got back from the DataSnap call, and I put the customer, the company name in the list box one's item text, right? And I could add a detail there, put the contact name, phone number, but I'll be binding those to some other parts of a customer form in the user interface. Very straightforward to build a DataSnap server. You can follow the steps in that Word document. If you want to use the MastSQL database, then in that Word document, just wherever you see department, put customer, and wherever you see in here get customer and orders, or wherever you see department employees, that is my query customer orders, right? So change department employee to customer order and leave the S on there. And then you'll work with the MastSQL database once you connect it up. Or you can use the employee database and just build the sample that they have in the tutorial if you want to build your first DataSnap server with REST and JSON and your first mobile client. The next steps for me is to add a little more user interface to the business app for putting up a customer form, letting you make changes to the customer. FDMEM table, I have a property there turned on for cached updates. So the FDMEM tables will cache. I'll probably add a user interface button for saving locally to JSON format, either XML binary or JSON. It's your choice, 3 options. And an orders list, which you saw, and then I'll click on that and you'll get an order form. You go and change the order. Maybe they wanted 2 different items or add a new order, and those go in the deltas. And then when I click the apply updates, it'll send all the changes back. So there's a little more work to be done in the order and customers part of our Marine Adventures app for employees. And but you can use that tutorial just as is, or substitute customer and orders for department and employees, and you could build the same one, similar one that I built. That tutorial uses a desktop client app. I built a mobile client app, but again, it shows you the steps and mechanisms for building a DataSnap server, putting databases in it, building a client, calling to the DataSnap server, getting data, changing data, and so on. So the DataSnap server just makes it easy, and it supports HTTPS and encryption filters, so you can build secure multi-tier applications. The data can sit in memory. If you don't save it locally, the data's in memory. So if you've got customer data and you don't want somebody to have it, don't save it. If you're disconnected, it has cached update as long as the app is running. If you get disconnected, then you can have a little status indicator that says you're disconnected. Reconnect, or maybe you're going through a tunnel and you don't have any cell coverage. Then when you're reconnected, call apply updates. It'll give you an error. We can put some error handling if the connection's not there, where you can test the connection. And so it has all of that built into the underpinnings. Really, all you have to focus on is what methods you want to have as part of your business logic, what databases you want to access, and where those databases are out in your infrastructure, on a database server somewhere, on a remote server somewhere, and then DataSnap running as a Windows command line app, or a Windows FireMonkey app, or an IIS DLL, ISAP DLL, or an Apache module. You can have your DataSnap server, put it on multiple servers and have clients have IP addresses to talk to different ones, so you can spread out the load. Again, it has security that you can build into the system yourself. One code base for building mobile and desktop clients to connect to the DataSnap server. Just use that TDS REST connection component. Right mouse click, generate the interfaces to the methods that are in the DataSnap server, and then hook up your user interface or some other business logic to get the data and metadata and do things with it. Lots of links in the slides. DataSnap links, the DataSnap filter compendium. That's in code.google.com/p/dsfc for DataSnap filter compendium. So you can look at that for other DataSnap filters that Daniel E.T.T. has collected together. I put the DocWiki FireDAC there again, just so you have it. That was also there from lesson 3. There's some videos on demand. Pavel did I'll have to add one. Pavel did a C++ mobile day, mobile client to a DataSnap server. He also did a Code Rage 8 Delphi last fall with mobile connection to a DataSnap server. So I need to add that. Or you can just search go to Code Rage 8 Delphi, and you'll find Pavel's DataSnap replay session there. Pavel's got blog posts about how to generate a certificate in his OpenSSL notes for DataSnap HTTPS. He's got his blog about his C++ builder, multi-tier database talk, and the sample code that he did for C++ Mobile Day. But you can look at that and see how you would do the same thing and watch the replay, the same thing in Object Pascal. Marco Cantu has a blog about using the JSON date reflect for DataSnap. And for the rest of DataSnap functionality, Pavel's got, I think, 11 or 12 tutorial lessons in his Delphi Labs DataSnap on everything from just a simple client that calls a remote method all the way through authentication, authorization, filters, security, HTTPS, everything that you can follow along. The only difference is back then he was using desktop clients. You could easily build a mobile client as well. So for next time, before next time, look at the DocWiki articles, watch some of the videos, go to the blog posts, follow the steps in that document to build your own DataSnap server mobile client, in that case, desktop client, but you can see how easy it is to build a mobile client versus desktop client. And I'll get this client and server zipped up as it is. I'll figure out what's going on and make sure it's all okay. And I'll put that up in the same zip file that the slides in that Word document are, so you can go back to Code Central. I'll let you know when the sample project's up there. The next 2 lessons Jim is going to do is I'll be down at Disneyland. And Jim is next Monday is going to be covering app tethering, how you can connect your mobile and desktop apps together using the app tethering technology that's available in the runtime library. In lesson 6, we've got the REST client components and backend as a service. So he's going to show you demos of how you might hook REST server access. You might have some REST servers out there where you need to get some information, get parts information from Amazon or whatever it might be, and hook that into your business application. And also use backend as a service. You might store your users or employees' objects out on the backend as a service storage, and also use backend as a service for push notifications to push down to your employees notices about back-ordered inventory or order has shipped to their customer, so they feel good that an order they took actually shipped to the customer. They could follow up. So backend as a service, push notification, storage, and so on. That'll be in lessons 5 and 6. Jim will be covering those next week, and that'll finish out the 6 lessons of the mobile school. So Jim, questions?
Okay, we've got a few questions here. What is the best way to store a username and password on a mobile device?
To not do it or encrypt it and decrypt it somehow. Prompt the user for it.
It's the best.
Huh?
Prompt the user, yeah, exactly.
Prompting, yeah. You can use the input query. The input query method, which I showed last time, it's used in the to-do list examples with SQLite and IBLite, the task list example or to-do list example. Input query, it has a prompt, and then you can specify an array of subprompts and inputs. So you could have, log in to the DataSnap server, and then as part of the input query call, 2 arrays, one with the 2 prompts for username and password text, and then the 2 variables in an array that you're going to get the results back from input query. So you could do that. Also, you could create your own login kind of little box if you want, but input query would work fine for that. And then just in memory, you'd store username and password in the TDS REST connection component properties in memory, and then you can connect to the DataSnap server and make method calls, get data, all that.
If you select a standalone to test, can you switch to a SAPI later? If so, how?
Not easily. The best way is to start with standalone and then use the wizard to generate an ISAPI DLL version or an Apache module, and then you would just copy the components from the other modules, because it generates different underpinnings for the main. There's no way to easily sort of replace source code in the project main. So, but I would build standalone, put all your database components. If we go back to the ID, put your database components, in the server module unit, and then you could just use that server module. So use the wizard to create IIS, but then delete the server module it generated and add the one you already had. Or you could just go like this, copy those and paste them, and go under the covers and copy and paste the implementation interface. But you can reuse the server module, no problem. You can reuse you'll get a different, you won't have an interface. The wizard won't generate this kind of form interface. And for the web module, it'll create a web module, but because you still have to have a DSS server and so on. The main program would be, for the DataSnap server, would be different. If we look at the source code here, all right, that's, it's got the, web module and so on. If it's, the application interface, create form and so on. So what I would do is I'd start with a desktop for testing and so on, and then you could just reuse the server methods unit, which has really the database access logic. Just create an ICE in your project group and ISAPI DLL, and for the server methods unit it created, just delete that one and go right mouse click and say add existing, or add ... which adds existing unit, and have the server methods unit. But there's no automagic wizard for saying I'm migrating an IIS from a desktop.
So Richard has a question. It says the DataSnap server interfaces directly with the database using the user account that is associated with the database, and the DataSnap client's security is handled by the DataSnap server. Is that correct?
Correct. But it could be
2 separate usernames and password.
It's separate, but you could have, if you have your user also having a user account in your database and granted rights, you could use that same user login to also make the connection to the database for that user. In my case, I'm in control of my DataSnap server, so I just used I buried into the connection parameters the username and password, right? Because I control that. It's in my data center somewhere. But I could also have the client give me username and password. I could have a method in my DataSnap server where I would pass that through, and then have logic in the DataSnap server when I made that call, set the username and password in the params of the FT connection, and then activate the connection, right? I had it auto-activate, but I could activate the connection. I could do that for each user that logged in, because maybe they don't have rights to certain tables, for example. The other way is to do user authentication and authorization, and then there's this role-based system in DataSnap where you can specify which users can see and can call server methods. So over here and I didn't do this, but you could, and Pavel covers it in whole detail, is you can put attributes around methods for different users that have the rights to see and call methods that are inside of your server class. So check out Pavel's Delphi Labs DataSnap. He covers all of that. in lots of detail.
The FD query customer names master data can contain parameters or apply filters that was sent by the client?
Well, it's parameters. Oh, in the queries, these are parameterized queries. So in my method call from the client to the server, to the DataSnap server, I'm passing the customer number, and that customer number is being put into the parameter of the query, and then the query is fired to get me back the customer I want and the orders for that customer that I want. In FD mem table, you could also do things on the client side. With an FD mem table, there's methods to do all sorts of things with FD mem table. If you want to do additional work, there's filter operations you can specify to filter the data based on maybe the user's rights when they log in. So you can do the SQL select on the server side. You can do filtering on the client side using FD mem table. Set a filter and then set the filtered property to true false. So you have all of those choices and opportunities.
So here's when I have a background service on mobile that communicates with DataSnap whenever the location sensor is updated, or is there a better way to implement that? You're probably going to run the battery out doing that, honestly.
Yeah, that's like running Waze or Skype or whatever. You could do that, and you could say, on location change, and set up a distance that the change would have to happen. There's sample of that in the mobile snippets location demo, where you can set the accuracy and the distance that causes a location change. So you could do that. That's how some of these, like UPS trucks and FedEx and all these other people, do certain things, right? They know the location of the trucks, and that might trigger them to do something based on where they are. The other way is the user would just start up the app and shut it down, and you get the location and do something when the user needs it. If you're trying to trigger a user, then you could do a backend as a service push notification, and then the logic for the push notification could check the location to see if it wants to start the app or not. I mean, start the app and then shut it down again. I mean, there's lots of different options there. On Android, you have a few more options as well to trigger an application to start. Yeah. You think of any other way on Android or iOS?
So I know Android has geofencing. We don't wrap it specifically, but it should be easy enough to do that, where you can set up a range and say, when I go outside this range, notify me, and then that, I believe, that sends a notification or an intent back to your application, which can then launch your application, and it can send the information, upload the information, set up a new geofence, etc. So by doing that, then you would only maybe set a mile radius that you want to say, every time I go outside this mile radius, notify me, update the location.
Yeah. Lucas, who left, he was asking about the Java proxy script generator. If you are using the wizard and you turn on the web option for samples, then it will generate all the JavaScript, HTML, CSS, underpinnings, the JSON parsing with JavaScript. It'll expose all the server methods so that you can call them from JavaScript. So you might have a PHP server on the back end. You might have you may have to build some HTML5 JavaScript stuff and want to connect to your DataSnap server. So all that gets generated. And again, you just have to run the proxy generator if you add or change any of the server method interfaces, parameters, or add server methods. So all that gets generated up front and can be updated through a proxy writer.
Does DataSnap support IPv6 now, or what would you need to do to add support for IPv6 and v4 at the same time?
So right now we're using the Project Indy components, and Project Indy has IPv6.
It does have IPv6,
okay.
So I would assume it should work, but I haven't tested it.
Yeah, and I haven't tested it either. So I think that Alf. You could go and drop a Project Indy component down and try it.
If you want to authenticate users against the same database as the one served by the DataSnap server, is there a way to do that other than defining a new set of FireDAC components that is used at startup of the server and when running invocation operations?
Well, FireDAC has the ability to do other server-side operations. There's some components. for doing server things where you could, for example, if the user put in username and password on the mobile client, you could have a method. You'd create a remote method in your server class to pass the username and password over, and then have DataSnap server-side code that would use that username and password and check to see if that user has access to the database or if they have access to certain tables. So you could do that on your own. You could also, and Pavel covers this in his Delphi Labs for DataSnap, user authentication authorization, where you could have your own list of users and verify that they can, that an app that they log into can call certain server methods. So check out Pavel's labs where he talks about user authentication and authorization. He has code and samples that show you how to use attributes. You can set attributes on some of the methods in the server class, and then those methods are not published, are not available to the user based on what they log in with. There's this role-based authentication that DataSnap supports. So take a look at all of that. Depending on the backend database, if it's interbase, there's also the IBX Interbase Express components that work across all platforms and devices. Those have, specific extended API component-based wrappers specifically for interbase. But also FireDAC, if you take a look at the documentation, exposes certain server-side capabilities in different databases as well.
How many concurrent accesses can be expected to be managed?
Hundreds, thousands, depends on the server speed, server memory. It depends on what the DataSnap apps are doing as well. You also may run into database connection issues. The nice thing about DataSnap is you have one application that's accessing the database from each server class. So you can, in a sense, do connection pooling. But if you only have 10 users for Oracle and 20 of your mobile apps are trying to get to it, then some may have to wait. So there's a lot of things there. Some people will keep a database connection alive and share the server class among multi-users, all sorts of tricks that people do. But we've got customers that are using DataSnap with lots of connections. I don't know if anything could handle tens of thousands. At the same time, you can put DataSnap servers on multiple servers and have some of your mobile apps call one IP address for the DataSnap server and call another IP address for a DataSnap server. We don't have a broker or a pooling or a load balancer, but it wouldn't be very hard to write a little simple server method that would go out on the DataSnap server side looking for other DataSnap servers that can serve up functionality and do your own round robin or load balancing, and then have lots of servers handling hundreds and thousands. So it wouldn't be very hard to write a few lines of code and a server method to send off the requests to other DataSnap servers. You don't have to have just one DataSnap server running on one server. DataSnap servers could also call server methods in other DataSnap servers.
What about dealing with briefcase and offline situations?
There, I use FD Memtable, and I'll put that in there. I'll put a save button to save all the FD Memtables, and that would save not only the data and metadata, but also the deltas. Because if you have cached updates turned on, there's in part of it I show it, I think, and it's in the tutorial Word doc. For FD Memtable there, and also for FD Query, there's a cached update property that you can turn active or true or false. So if you do that on FD Memtable and save it to a binary, that'd probably be the fastest way, because then you wouldn't have to parse it coming back from XML or JSON. And so I'll put that in the final project. I'll have a save locally button. That way you can save and then restore from a binary FD Mem storage for each FD Memtable. Make additional changes, then reconnect to the DataSnap server and go through the apply updates process. So there's your briefcase model. It's all handled for you by using FD Memtable.
And does FD Memtable require a interbase license?
No.
IB2Go or IB2Go?
No, you can use FD Memtable all on its own. You just need FireDAC. So that part is local. It's in the Pro version. And in both versions of app methods. So FD Memtable is a replacement for client dataset, and it plays very nicely with all the rest of the FireDAC components. Or you can use it on its own as a lightweighted. It even has its own filtering Yeah, and I'm I answered some about people wanted, apply updates and error handling and what if an error occurs and how to handle it. So I'm going to finish up the apply updates part, and I'll put in some error handling to pop up notices or whatever based on the error that takes place. In the apply up in the deltas, there's the original value and the changed value for everything that you changed in the cached updates. So you get some information about what the problem was when the error happened, and there's some programmatic ways you might be able to do something. There's also on error on the connection. There's a couple other events you can handle, and of course you can use try statements around certain blocks if runtime exceptions take place. Versus apply updates, you get an error ID, an error count, and you can deal with it. Skip an update and so on. So there's documentation in the DocWiki for apply updates in FireDAC and cached updates that you can explore. So I'll put some of that in. It's also in the Word document tutorial. They have the apply updates on the client and server side. So I'll get that into this project before I post the project source code in the Code Central zip file for lesson 4.
Using the FD mem table and persisting it all locally, only going to persist the data that's currently displayed. Is there easier way of having it persist more data than is currently been requested?
Well, you'd have to request all the data and save it off, I guess. You could have another FD mem table that's sort of a clone, and every time if you clear out an FD mem table and get some more, you could read through it and put it in another FD mem table and keep one that's smaller and one that keeps being added. That's one way of doing it. You could, there's check out the FireDAC caching documentation, and there's some strategies there, but that's one way to do it. Is that you would have the binding of the user interface to the row sets that you care about. There's also row set value, that's a property, and the fetch options for both the queries and FD mem table. So you can fetch some at a time, and then under the covers, if you need more, you'll get more. You'll get the next whatever that number is. The default right now is 50. And my in the MastSQL customer table, it has 55 customers in the database. So when I had fetch row set to 50 and I did select star, I ended up with 5, and it was the last 5 in the table, the customer table. And I thought, oh, wow. And that's when I changed the row fetch size to 100. So it does handle the paging, but if you need to bring it a little bit at a time, have the binding to the one, I'd use 2 FD mem tables. And have one that's sort of growing and being appended to, and the other one just cleaning it out and getting the next row. That's what I'd probably do to be the fastest, I think. And you can assign FD mem tables to each other. So if you wanted to get all of them, you just FD mem table 1.data equals FD mem table 2.data. We showed that on lesson 3, assigning the query data into an FD mem table. And the data and metadata it's one assignment statement. That's pretty cool. Is there a DocWiki on deploying real REST server on EC2? No, there really isn't. It's not that hard. Pavel does it actually in his. You'll see him use his Amazon EC2 instance to put his DataSnap server on there. So it's really following the Amazon EC2 documentation on creating an instance, getting an elastic IP address, so you have an IP to refer to. And then you just copy up your DataSnap server, and if you want your databases there and anything else, copy those things up. And now you've got your DataSnap server running on EC2. Jim did put out an Amazon deploy. That's the AWS deploying an app, download app, and so on. I've got an EC2 instance with an elastic IP address, and I just RDP to it and copy my files over, and it's there. And Pavel shows it running on Amazon. His DataSnap server in his C++ mobile school and mobile day, and I think he may have done it also in his Delphi Code Rage 8 session on DataSnap. So it's more just copying the DataSnap server executable or whatever, and if there's any other supporting files your DataSnap server needs. Okay, everybody, and Jim, thanks a lot. And
sure.
Everybody, you got Jim next week for lesson 5 and 6. Bye.
Great. Bye.